Okay, so based on some feedback of the other videos, I'm going to do a video today on the Le Chatelier's principle from my viewpoint and see if this might clear up some misconceptions. So first of all, just a quick review here. If you can take time to write the equilibrium expression and come up and solve for the equilibrium constant given the concentrations at 500 degrees Celsius, and then determine which side is favored. Go ahead and pause the video and then return when you have those answered if you need some more practice. All right, so let's go with the first part. The first part, we have that the equilibrium constant, and I have it written there and you can check your work. All right, if you're going to continue, go ahead and pause the video and plug in the values for the concentrations and see what you get for the equilibrium constant. Start it again when you have your answer. So here we have the actual equilibrium constant is equal to 1,200. So what does that mean? Well, because the equilibrium constant is greater than 1 and is significantly greater, that means that the products are going to be favored. Or you could say that the forward reaction is favored. Okay? Forward reaction is favored over the reverse reaction. So let's continue with this and see, well, what if I want to produce more produce more reactants or produce more products and have the equilibrium shift a little bit? And that's what today's lesson is about. Le Chatelier's principle in general says that a reaction will shift when it's at equilibrium, it will shift towards the reactants or products to relieve a stress. No one likes stress. We try to get rid of the stress in our lives, just like a reaction would try to get rid of the stress. So let's pick this definition apart a little bit. What does shift mean? Well, shift means that it will either produce more products or reactants. What is a stress? So a stress is a change in concentration, in temperature, or in pressure, or you could even say in volume, because volume and pressure are related. So in those three stresses, it's going to counteract to that change and change the equilibrium, shift it to the right or the left, shift it to the products or the reactants based on relieving that stress in some way. This does not change the equilibrium constant as long as the temperature doesn't change. So if I do provide the stress of changing temperature, it'll change the constant. If I change concentration or the pressure, your equilibrium constant actually will not change. It will, however, change how many reactants or products there are. So taking a look at this reaction, again, that we started with, you'll notice it's a reversible reaction to produce ammonia. Notice that the heat of reaction is negative. That means that it's exothermic. It's important to realize that exothermic means I'm going to treat heat as a product. If it's endothermic, I'm going to treat it as a reactant, and that'll come up later here in our lesson. Our equilibrium constant is smaller than 1 at room temperature. Remember, I changed the temperature, it's going to change the equilibrium constant. So this means it's going to favor, take a moment and think, hopefully you say the reactants because it's smaller than 1. However, this is an important reaction that we want to actually produce ammonia. If you watch the information about the Haber process, about Fritz Haber, you'll understand that ammonia is a very important in production. It can be very useful for good and for bad. So throughout this video, throughout this PowerPoint, we're going to look at trying to produce more ammonia. In other words, we want it to favor the reactants, favor the products, or favor the forward reaction. So in this reaction at room temperature, I can tell you, we said it favors the reactants. It really does. 99% is going to be reactants and only 1% products. We want to shift that so that it's more of the products. So the first stress we have, a reaction will shift away from an increase in concentration and towards a decrease in concentration. Put that there for you. There we go. Shift away. So how does that work? Okay, well, if I want the reaction to shift toward the product, in this case, we want it to favor the products or favor the forward reaction. So if I'm going to increase hydrogen, Remember, it's going to, if I increase it, it's going to shift away. If I decrease it, it's going to shift toward. Well, if I want to shift toward the products, then I want to increase the hydrogen. So it'll shift away, producing more product. Okay, likewise, nitrogen. Nitrogen is a reactant. If I increase it, it's going to shift away. If I decrease it, it's going to shift towards it. So again, I want to shift away from the nitrogen, from the reactants. So I want to increase the nitrogen to produce more ammonia, to favor the product or to favor the forward reaction. What if I look at the concentration of the ammonia? Well, again, if I increase it, it's going to shift away from it. If I decrease, it's going to shift towards. Now, be careful here. So in this case, if I increase the concentration, it's going to shift away, which would make it shift this direction. If I decrease it, it's going to shift toward it, which would actually be this way. So what do I want? I want to shift it toward, so I'm going to decrease. It's going to produce more. So first stress, the reaction, changing the concentration, shift away from an increase, shift toward a decrease. Second stress is the temperature. First, as I showed you before, determine if it's an exo or an endothermic reaction. If it's exothermic, put heat on the product side. If it's endothermic, put heat on the reactant side. So, and then you can just treat the heat like the concentration that we did. So if I already told you that the Haber process is a exothermic reaction, we can see that heat is on the product side. So if I would increase the heat, it's going to shift towards it. Well, shift towards it would mean, I'm sorry, let me rephrase that. Boom. If it is exothermic and I increase the heat, it's going to shift away. Well, shifting away will mean it's going to go in that direction because the heat is on the product side. If I decrease the temperature, it's going to shift towards it, which in this reaction would mean it's going to shift toward the product side. So which do I want to do? If I want to, again, shift toward the products, well, I want it to shift towards the product by decreasing the temperature, lowering, cooling it down. It will try to produce more ammonia. The third stress is the pressure. We're going to focus on gases. Now in this case, we're going to look at the number of moles. An increase in pressure causes the equilibrium to shift towards the side with fewer moles, because fewer moles means fewer collisions. If I increase the pressure, I want fewer collisions to kind of equalize that pressure again. A decrease in pressure, we want to have more moles. It's going to shift towards the side with more moles because more moles would mean higher pressure. So if I decrease the pressure, it wants to bring that pressure back up. So changing the gas pressure is like changing the concentration. More pressure, it wants to get rid of that pressure. So it's going to shift to the side with less moles. Less moles wants to replace that pressure, increase the pressure again. So it's going to switch to the side with more moles. So how do I figure out the number of moles? Well, I look at the coefficients. In the reaction here, I have 3 plus 1 moles for my reactants. I've got 4 moles on my reactant side. On the product side, I only have 1 product, so that coefficient is 2, so I have a total of 2 moles. So if I want it to shift towards the products, I'm wanting it to shift to the side with fewer moles. So what do I need to do to my pressure? I want to increase to the side, increase my pressure will cause it to shift to the side with fewer moles. Volume. If you consider how it would affect pressure, following pressure's rules, remembering Boyle's law, remember that pressure and volume are inversely related. So again, if I want it to shift towards the products, that's my goal here in this particular problem, shift towards the products, I want it to shift to the side of fewer moles, which means I want the pressure to increase, so my volume will have to decrease. So to increase pressure, we'll have to decrease the volume. So after we do all this, guess what? We can look, and we now have equilibrium balance becomes 50% reactants and 50% products, and we indeed increased the amount of products. And in fact, this particular process, since they collect it and the reactants are recycled, they eventually get a 97% yield, which is pretty remarkable when you go from a 1% to a 97% yield. So let's just kind of look here a little bit with the examples. You can pause this, take a look. If I want it, now again, I'm going to ask, you have to read these questions. I want it to make more products. So what do I have to do to these stresses? So pause and come back when you have those answers and see how you do. So let's take a look, okay? If I want it to shift this direction, I'm going to have to increase my concentration of my reactants, so it will shift away, and decrease my products because it'll shift towards a decrease of concentration. In this case, you can see it's endothermic, so heat would go on the reactants side. So if heat is treated like a reactant, I want to increase the temperature, so it'll shift away to form more products. Pressure. If I take a look, I have 1 mole of gas on my reactant side, 2 moles of gas on my product side. So I want it to shift towards the side with higher, more moles. So I'm going to decrease my pressure so that it shifts to the side for more moles. Volume, I'm going to need to do the opposite. I'm going to need to increase the volume to decrease the pressure. Okay, again, you can kind of pause this if you would like to answer these questions. I'm just going to go over them very quickly. Here we go. A reaction shifts towards an increase in concentration. That's false. It shifts away. Adding heat to an exothermic reaction makes the equilibrium shift toward the reactant side. Well, exothermic means heat would be a product. So if I add heat, it's going to shift away, which would be towards the reactant. So that is true. Increase in pressure causes a shift toward the reactant side. Well, that depends. Which side has more moles? We're going to say it's false because it's just going to shift towards whichever side has the fewer moles. Changing the volume of a reactant will not change the equilibrium concentrations. This is false. Changing the volume will change the pressure of any gas in the reaction. Therefore, it will change the equilibrium concentrations. If you're good, you can just stop and do the work. We'll just look at these last examples here. So in this first case, what will happen if I add HBr, hydrogen bromide gas? Well, if I do that, it's going to shift away. So it's going to shift towards my products or favor the forward reaction. If heat is added, you'll notice that it's endothermic. So that means, I want to write heat here. So if I add heat, it's going to shift away. So the same effect will happen. It's going to shift towards the right or shift towards the product, favoring the forward reaction. If I increase the volume, oh, here's a little tricky one. I'm going to have 2 moles on my reactant side. I actually only have 2 moles on my product side, so it will have no effect because it has equal moles. Looking at the next case, if I add hydrogen, well, hydrogen is a product. It's going to shift away from an addition of the concentration, so it's going to shift towards the reactants or favor the reverse reaction. If pressure is increased, well, notice this is not a gas, so we're not going to affect that. This is not a gas, not going to affect that. So I have 4 and 4, so again, there's no change because they have equal moles. Temperature increased. Well, now we have an exothermic reaction, so we're going to add it to that side, which means it will shift to the reactant side. Sometimes you'll have, in this case, they either both shifted to the right or both shifted to the left. That's not always going to be the case. So if you have any questions, let me know. I know this is a little long, but I knew some people were still struggling with it. So use this for what you want and ask any questions you might have. Have a great day.